Hey class, in today's lesson we're going to talk about probability, which is found in section 9.7 part 1. Our objective is to find probabilities of events. The probability of an event, so any happening whose result is uncertain, is called an experiment. The possible results of the experiment are outcomes. The set of all possible outcomes of the experiment is called the sample space of the experiment. And any sub-collection of a sample space is an event. So it's kind of like a hierarchy. So the entire thing is called an experiment. Outcomes, possible results of experiments are outcomes. The things that make up the outcomes come from a sample space. And the things that make up a sample space are each event. Okay? All right, so all we're going to do within this problem is we're just going to identify the sample space for each of the following events. So if a coin is tossed, we're going to write the sample space for that. So the sample space for this would be S is the set of heads and tails. Okay? If a coin is tossed 2 times, then the sample space is heads, 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 tails, tails, heads, and tails, tails. Finally, if 3 coins are tossed, we have a larger sample space. I'm going to switch colors at the bottom. So then our sample space, didn't mean to use yellow though, sorry. Our sample space will be heads, 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 tails, heads, heads, tails, tails. Then we will have tails, 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 heads, tails, tails, heads, heads, and I think I'm missing one. Oh, tails, tails, heads, and I'm missing another one too. I figured it out. Okay, so it should have been heads, heads, tails up here. Sorry. All right, so that would be that sample space. All right. So it says if an event E has N of E equally likely outcomes and its sample space S has N of S equally likely outcomes, and the probability of an event is the probability of N of E over N of S. So let's take a look at what that means in particular. Well, before we do that, a little bit more vocabulary. So it says, because the number of outcomes in an event must be less than or equal to the number of outcomes in the sample space, I'm supposed to say in the sample space, the probability of an event must be a number from 0 to 1 inclusive. So if P of E equals 0, then the event E cannot occur, and E is an impossible event. That means it cannot happen. If P of E equals 1, then the event E must occur, and E is called a certain event. All right, so in our example, it says 2 coins are tossed. What is the possibility that both land heads up? All right, so E is the event that we want, which is for it to be heads, heads, okay? And so it comes from a sample space of either heads, 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 tails, tails, heads, or tails, tails. So then what we would write is that the probability of the event taking place would be the number of the actual event occurring over the number of the sample space. So the number of elements that we want to take place is only 1, and then the amount of elements in the sample space is 4. So you have a 1/4 of a chance of flipping 2 coins and both of them landing heads up. And the second one, it says a card is drawn from a standard deck of playing cards. What is the probability that it is an ace? So the event that we want is to draw an ace. And in a deck of cards, there are 4 aces in a deck. And a deck, which would be the sample space, has 52 cards. So then our probability of the event occurring would be the number of elements in the event over the number of elements in the sample space. So that is 4 over 52, which reduces down to 1/13. So you have a 1 in 13 chance of drawing an ace from a standard deck of cards. All right, so if we try this one, there are two 6-sided dice that are tossed. It says, what is the probability that the total of the 2 dice is 7? So the first die, the numbers on that are 1, I shouldn't put commas, 1, 2, 3, 4, 5, and 6. The second die, the numbers are also 1, 2, 3, 4, 5, and 6. So the probability of the event occurring, and by the way, all of these, the only ones that, and I should go back. So on the second die, if I want a total of 7, then that means the second die has to be 6. The next one on here has to be 5. This has to be 4. This has to be 3. This has to be 2, and that has to be 1, right? Because we want a total of 7 each time, right? If I added them vertically, I would get 7. So then that means there are 6 possible ways, or 6 ways, that we can get a total of 7, which is our E. This stylus is terrible. Okay, and then so the amount of numbers in a sample space would be the 6 numbers for die 1 times the 6 numbers from die 2. So the probability of the event occurring will be the number of elements of the event versus the number of elements in the sample space. Like I said, for the event to take place, there are only 6 ways that can take place. However, for the sample size, like I said, there are 6 possibilities on the first die and 6 possibilities on the second die, so that gives us 36. So when we're done, it is a 1 in 6 probability that when you roll 2 die that are 6-sided, that you'll get a total of 7. All right, let's look at example 3. It says a 12-sided dice can be constructed so that each of the numbers from 1 to 6 appears twice on each die. Prove that these dice can be used in any game requiring ordinary 6-sided dice without changing the probabilities of different outcomes. So essentially, our event is going to be the probability of each occurring once. So for us, the probability of that event happening would be the number of elements of the event divided by the number of elements in the sample space. And the number of elements, the number of elements in the event would be 2, because that is, we're talking about 2 dice versus 1 12-sided dice, right? And the amount in the sample space is 12. So when we're reduced, we get 1/6, which, by the way, is the exact same probability that you would get if you just rolled 1 regular die. So they are the same. All right, in example 4, we're talking about the probability of winning the lottery. People try to do this all the time, right? So it says in a state lottery, a player chooses 6 different numbers from 1 to 40. If these 6 numbers match the 6 numbers drawn by the lottery commission, the player wins or shares the top prize. What is the probability of winning the top prize? So let's think about something. So first we have to talk about the fact that if there are 6 numbers, but there are really 40 different numbers that you can choose from, that's automatically a combination. So let's talk about the amount of different numbers that you can have. So that would be a combination of 40 numbers choosing 6 at a time. I've probably at this point shown you how to do that in your calculator. So that answer would be 3,838,380. All right. So our probability of that event taking place would be the number of elements in the event, which means one top person, over the number of elements in the sample space. And there are 3,838,380 elements in the sample space. So you have a 1 in 3 millionth chance almost of winning the lottery if there are 40 numbers to choose from and you can only pick 6 at a time. All right, let's move on to our last example. All right, in this example, it says if one institution is selected at random, what is the probability that the institution is one of the 2 north central regions? So first, there are, for the north central regions, there is a west north central and there is an east north central. Okay, so it says if these are the numbers of colleges and universities in a region, and we put them all together, what's the probability of pulling one that comes from the north central region? So with that being said, the probability of the event taking place would be the number of elements in the event divided by the number of elements in the sample space. Well, the number of elements in the event, what we want to take place, it comes from those 2 schools, so that's 397 plus 578. And it's divided by the total amount of universities. So our sample space is the total amount of colleges and universities in all regions, and so that's 3,696, which is equal to 975 divided by 3,696. And so that probability is about 0.264. So if we think percentages, that's about a 26% chance of pulling something from the north central region. All right, guys, that is our time. So if you have any questions, again, please be sure to come see me for tutoring.